Good afternoon and welcome to CHM122. For the past 2 weeks, we have been on quantitative analysis, acid-base titration, and redox titration. But for this week, we are going ahead to qualitative analysis, and we're going to be looking at group 1 and group 3 cations and anions. What do we mean by qualitative analysis? Qualitative analysis involves identification of the ions present in inorganic salt. When an inorganic salt is heated, it can actually decompose. And when it decomposes, we'll be able to get a gas, and we'll also be able to identify the anion. Invariably, the gas is actually coming from the anion. Aside heating, we can also get liberation of the gas via dilute HCl or conc H2SO4. Now, what are the steps in qualitative analysis? We have the physical examination, which will include the color, the odor, and the texture. For the color, we're actually trying to see, is it a green? Is the color of the salt green? Is it pink? Is it white? Is it red? Is it blue, purple? We have different colors of salt. So we should be able to say if it's a green powdery salt, it's a pink crystalline salt, it's a white powdery salt. So whatever the texture is, we should be able to put it down and also check if the salt has an odor. So for our physical examination, we look at the color, the odor, and the texture. Aside the physical examination, we also look at the dry heating. For the dry heating, we look at the color change during the dry heating. I have tried to put up example of what is expected from us in the lab. So this is our boiling tube where we put our salt and we try to heat using the Bunsen burner. So once this is done, we'll be able to examine if there's a color change in the salt, that is change in color of the residue. Aside the change in the color of the residue, we should also be able to identify the gas that is involved. If it's a colorless gas, if it's a colored gas, and from the gas, we'll be able to know the anion. And when we are doing the dry heating, we also try to identify if the litmus paper has action on the gas. So invariably, if there's action on the gas, the red litmus paper might turn to blue, or the blue litmus paper will turn to red. So during our dry heating, we are looking at three things: the color change in the residue, the odor and the color of the gas, and the action of the gas on the litmus paper. And it's always good to use a damp litmus paper. And with that, you'll be able to know if the gas is acidic or if the gas is basic. And I always advise students to do the action of gas on litmus paper during the dry heating. Now, if during the dry heating we are not able to liberate any gas, we can then discard whatever we have here, wash off the test tube properly, and dry it. Then we'll take another pinch of the salt into the test tube and add the dilute HCl to see if we can liberate a gas. If we do that and we can't still liberate any gas, we discard it, wash off our test tube, dry it, take another pinch of the salt and add conc H2SO4. By the time we do this, we should be able to liberate a gas. And we can check table 1 on page 11 for the color and odor of gases that can be liberated. Now, once the gas have been liberated and we will be able to identify the gas and the anion, we can then go ahead to do a confirmatory test for the gas. And we can get this on page 11, table 2. So once we have done the confirmatory test for the gas, we also do confirmatory test for the anion, which can be obtained on page 12 to page 13. We also do tests for the cation, and we also do the confirmatory test for the cation. Now, for the confirmatory test for your CO2 will actually turn your lime water milky. For your NO2 gas will actually color the test tube. You actually see that your test tube turns brown because it's a reddish brown gas. And the confirmatory test for your NO2 is actually the brown ring test. And for the HCl and the ammonia gas, we actually use the white film to identify those gases. Now for this week and next week, as I said, we are looking at our group 1 and group 2 salt analysis. So we are going to test for gases, we test for corresponding anions, and we test for cations. So for the identification of group 1 and group 3 cations and anions, we are going to report on our manual on page 26 as test, observation, and inference. First of all, we look at the physical appearance. As I have told you, look at the color, the odor, and the texture. And we see the inference on page 21 and table 1. When we are done with the physical appearance, we test for the gases and the anions. How do we go about this? I've already explained. First of all, we do the action of heat on dry salt. We look out for the color change in the residue, where we can get the reference in page 21, table 6. We also look at the gas evolved. From the gas evolved, we'll be able to identify the anion, and we can get these inferences on page 23, table 8. Also check page 11, tables 1 and 2. We also do the action of gas on litmus paper, both on the red and blue litmus paper. And we can see the inferences on the red and blue litmus paper on page 11, table 2. As I said, for the action of gas on litmus paper, I encourage students to do this via dry heating because the dilute HCl and the H2SO4 are both acid and they can have some effect on your blue litmus paper. Now, for the anion test and for the anion and the gas, how do we go about that in the lab? First of all, how do we report? So we start with our salt A. It always include the code of your salt. So we have our salt A, we look at the color, the odor, and the texture. We get our inference on page 21. Then number 2, we look at the salt A plus the heat. So we look at the change in color of the residue. We can get that inference on page 21, table 6. We look at the color and the odor of the gas evolved. We can get that on page 11 and 12, table 2. Then we also look at the gas evolved plus litmus paper. We look at get the observation and we also give the inference. Now, as I said, when we have done dry heating, we cannot observe any gas. Then we go on with our dilute HCl or H2SO4. By the time we do either of these, we should be able to get the color and the odor of the gas, and invariably, we should be able to suspect a gas and we also suspect the anion. Once we have been able to suspect the gas and the anion, then we go ahead to carry out a confirmatory test for the gas, which we can get on page 11 and 12, table 2, and we also carry out a confirmatory test for the anion. Now, for the confirmatory test for the anion, we can first of all, we usually have to prepare the original solution. How do we prepare original solution? We take 0.2 gram of the salt sample in the test tube and dissolve in distilled water. Once we get a homogeneous solution, that is, once the salt is completely dissolved, then that is our original solution. But if the salt is not completely dissolved, then we can proceed on page 22, table 7, where we discard whatever the original solution we have prepared that was not completely soluble. But please, during the preparation of original solution, when you add the water to the salt and it's not soluble, let's try and heat it up because we already know that solubility increases with temperature. Sometimes we can get it soluble with increase in temperature. But if after doing that it's not soluble, then we discard, take another pinch of our salt and add dilute HCl and see if we can get it dissolved. If it's not dissolved, we try dilute nitric acid with a fresh pinch of salt. Once we get it dilute using either dilute HCl or advise to dilute that solution with water before we carry out the analysis using the original solution. So once we get the original solution out, then we proceed to the confirmatory test for the anion, which can be found on page 12 and 13, table 3. So that is the test for your anion and your gas. So for our group 3, I'm not going to repeat the test for the anion because it's the same procedure. We can only repeat for the cation because we have different cations. But for the anion test, it's the same procedure to be able to identify the gas and the anion. So for the cation of group 1, we start the cation test by preparing original solution. So we have our salt A plus water. If it's soluble, we say our original solution is prepared. If it's insoluble, we proceed on page 22, table 7, to get our original solution. Once we have our original solution, which is our OS, so we say that OS plus dilute HCl. Once you get a white precipitate, then invariably group 1 cation is present. So we are going to precipitate our group 1 cations using dilute HCl. So to the white precipitate, we are asked to wash. How do we wash our precipitate? We add the water to the precipitate and allow it to settle. Once it settles, we decant the water. That is how we wash our precipitate. So the washed precipitate plus 5 to 7 cm cube of water and we boil. If the precipitate dissolves, lead is suspected, or a precipitate is insoluble, then we are suspecting mercury or silver. So invariably, why do we boil the precipitate? Is to see if we'll get the precipitate to dissolve or the precipitate to be insoluble. Now, if the precipitate dissolves and we add acetic acid and potassium chromate solution and we get a yellow precipitate, then we are suspecting lead. Now, to the yellow precipitate and you add your sodium hydroxide and you get a yellow precipitate soluble in sodium hydroxide, that actually confirms your lead. Now, if you recall from number 4, we had 2 scenarios here. It's either the precipitate dissolves or the precipitate is insoluble. For the precipitate that dissolves, we are able to confirm our lead. For the precipitate that is insoluble, we then proceed to add ammonia, and shake. So to the insoluble precipitate plus ammonia and shake. If the precipitate dissolves, then we are suspecting silver. Now, if the precipitate is insoluble, then we are suspecting mercury. Now, to the insoluble precipitate, if it turns black, then that confirms your mercury. But to the precipitate that dissolves and you add dilute nitric acid and you get a white precipitate, that confirms your silver. So this is how you are going to confirm either your silver, your lead, or your mercury, which is your group 1 salt. And this is actually a picture of when we say precipitate. Most of you will observe this in the lab. So when you see this, you know what we mean when we say precipitates. For your group 3 gases and anion, as I said, I will not repeat it. You just refer to slide 7. It's the same procedure for your gases and the anions. So for your group 3 cation, as I said, we start with the preparation of original solution. You prepare your original solution, you give us the observation and the inference. To the OS, you add 5 drops of corn nitric acid and you boil for 2 to 3 minutes. You add your ammonium chloride and your ammonium hydroxide. If you get a precipitate, then your group 3 cation is present. So for your group 3, you are going to precipitate the group 3 cations using your nitric acid, ammonium chloride, and your ammonium hydroxide. Ammonium hydroxide. Yeah. So now to the precipitate form, if you add sodium hydroxide and your hydrogen peroxide and you boil for 2 to 3 minutes, if the precipitate dissolves, then you are going to suspect ion 2 or ion 3. But if the precipitate is insoluble, then you suspect chromium or aluminum. Note, why do we boil the precipitate? Is to see if the precipitate will dissolve or the precipitate is insoluble. Now, if the precipitate dissolves, we proceed to confirm chromium or aluminum. The observation and inference are all inside your manual. So you take your time before you go to the lab and try to complete the slide. Then if your precipitate is insoluble, You proceed to confirm ion 2 or ion 3. As I said, the observation and inference are all in your manual. Please take time, read through your manual, as everything is contained in the manual. Thank you and have a successful laboratory.